Hello, everyone, and welcome to today's Single Store Dev Day and Happy Hour at AWS Seattle. My name is Matt Brown, and I will be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower right-hand corner of your console. Regardless of whether you're attending virtually or here on site, please submit your questions through the GoToWebinar console so that the entire group can benefit from the Q&A. For folks that are attending here live in the audience, first of all, keep your laptop sound off. And secondly, you're welcome to raise your hand if you'd like any additional help. We've got some solutions engineers that are going to be floating around the room who can come to your side if you need it. So let me introduce our speakers for today. Gabe Cafferty is a solutions engineer at SingleStore, and Saurabh is a partner solutions architect here at AWS. Welcome, everyone. Gabe, you now have the floor.
Awesome. Thank you, Matt, and thank you, everyone, for attending in person and virtually here. Looking forward to a fruitful session here, so we'll get started. So today we're going to talk about real-time operational analytics and how SingleStore and AWS work together to deliver these types of solutions to customers of all shapes and sizes in many different industries. So as Matt mentioned, my name's Gabe. I'm a solutions engineer here at SingleStore, and my co-presenter Saurabh is a partner solutions architect at AWS. Quick breakdown of today's agenda. We're budgeting roughly 90 minutes for this session today. So we're going to do a quick intro, and that's going to cover intro to SingleStore and then how SingleStore and AWS partner together and what integrations we have. We're going to do a workshop prep session, which is section A here. So that's getting your SingleStore environment provisioned, getting your AWS environment provisioned. We'll do a little short break where we'll have some questions and have some swag giveaway. For part B, we're actually going to do the hands-on, create databases, load data into tables, connect SingleStore to AWS services, and see some actual data flow. And then at the end, we will do a recap and clean up the resources that we provision throughout this. So the workshop teaching format, basically there are a few different resources to leverage throughout this workshop. So there is a presentation guide and there is a student guide. So it's a slide deck, and the student guide is actually the instructions about how students can go through and perform the whole end-to-end workshop, as well as a GitHub repo, which we're going to be cloning to our AWS environment, and Matt is posting those resources in the GoToWebinar currently, or maybe he already has, but
Posting them very shortly here.
Okay, nice. All right, so keep an eye on the chat for those links for those resources, and then feel free to download those. And yeah, without further ado, we'll get going here. Yeah, so quick GoToWebinar PSA. We will not be using the questions portion of it. So any questions that arise throughout this session, please drop those in the chat, and we'll pick them up there. We have people monitoring the chat virtually, as well as some SingleStore employees in person to help with any questions that arise throughout this. All right, so SingleStore overview, a little SingleStore 101 here. Just high level in one sentence, SingleStore is a real-time distributed SQL database. So we all know what a database is. It's something that you read and write data from, but for these other pieces, when we're talking about real-time, we mean the ability to ingest massive amounts of data into a database and then query that data immediately. We're talking about millions of records per second coming into the system, and the millisecond those records hit the system, being able to query them, enabling real-time applications and analytics. Distributed, so single store, as opposed to many traditional monolithic databases, is distributed in nature across many different machines. And we have a few different categories of machines that our database gets distributed across, both aggregators and leaves. And SQL, we all know and love SQL, super easy way to speak with and manage relational data. But one of the big differentiators of single store is actually our ability to handle more than just relational data. So we'll get more into it in a couple of minutes here, but single store is a real-time distributed SQL database. We also like to call ourselves an HTAP database, so hybrid transactional and analytical processing, as opposed to the traditional styles of databases, OLAP and OLTP. We're right at the crosshairs of that Venn diagram. So we said single store is a real-time distributed SQL database. So just a few key capabilities of real-time that we want to touch on here. Ultra-fast ingest. We're talking about getting millions of events per second, whether that's through a stream or through batch processing into the database. Super low latency queries, single-digit milliseconds on this massive amount of data that's getting ingested under high concurrency. So whether it's an application or an analytics type of use case, we can scale out to support hundreds, thousands, tens of thousands of users concurrently. So that was kind of the single store 101, and now we'll discuss what the actual technical differentiation is. What under the hood is unique about single store? So first and foremost is our patented universal storage architecture. So I'll just go ahead and build this slide out. Basically, our universal storage architecture allows a single table to span memory, disk, and object storage, intelligently moving chunks of data throughout these three storage tiers. So in this one table type that spans these three different medias, we can house many different data types, including relational, JSON, CSV, full text search, time series, key value, you name it, all within our universal storage table type. And how the universal storage architecture works is the millisecond you write a record into the single store database, it hits memory and it's immediately queryable that millisecond. It accumulates in what we call an in-memory sidecar, and then we are asynchronously flushing that in-memory sidecar down to local SSD, where we accumulate all of that data, and then from there we are asynchronously tiering data based on a least recently used algorithm. So we're taking cold chunks of data from SSD and tiering them off to object storage on the 8K block level. So any data that you need to have low latency will live on local SSD and in memory, and then any data that has a looser SLA for query response time can then overflow to object storage, getting you the benefits of lower cost storage for that data, whereas the higher cost, higher performant media types will only have that mission critical data on it. Come on. Another key differentiator of single store, we talked about real-time streaming, ingesting millions of events per second. This is how that is possible in single store, is our core engine feature called pipelines. So we talked about how single store is a distributed database. So pipelines allow us to leverage all of the resources on all of these distributed machines in parallel to have massive amounts of throughput with super low latency into our database system. So let's say you have an environment with 128 cores. You can leverage all of those concurrently with our pipelines to process massive amounts of data in flight into the system. And just a few key points about pipelines that you can see here. We have exactly once semantics, transactional consistency. Our main integrations with pipelines are Apache Kafka, cloud object stores, whether that be S3 or any other cloud object stores, as well as HDFS. And then the supported data types are JSON, Avro, Parquet, and CSV. You can have those as just plain data formats or compressed data formats. And then the final point about pipelines is the ability to manipulate data. So pipelines by no means are a full-blown ETL tool, but they do have the ability to do some lightweight data modification in flight into the database. But when we say into the database, what does that actually mean? We can have a few different destinations for pipelines within single store. You could have the destination of a pipeline be a table, obviously. You want to have a big pipe of data coming in and just dump it in a table. But you can also pipeline data directly into a stored procedure or a UDF. So you can have your custom logic manipulate the data in flight, in memory, before it's ever persisted to the table. And we see this as a big unique differentiator for single store, the ability to have this massive amounts of data ingested in real time. And yeah, pipelines are great. Easy as that. All right, so next technical differentiator here for single store is what we call workspaces. So workspaces from a high level is the ability to create isolated compute swim lanes for particular workloads. So the highest level paradigm in our cloud managed service is a workspace group. Within a workspace group lives both workspaces and databases. And those workspaces and databases can have a many-to-many relationship, whereas one workspace can have many databases attached to it. One database can be attached to many workspaces, and those can be configured in both read-only as well as read-write configurations. But the real benefit of workspaces is the ability to isolate particular workloads to avoid the noisy neighbor problems that we're infamously know in the database industry, where an errant query or a intensive user is regularly consuming excessive amounts of resources within the environment. Workspaces allows you to configure exactly how many resources each workload is intended to consume, and it will never go past that. So yeah, separation of compute and compute. We can create these different compute buckets. In the field, a way that we see this implemented very frequently, for example, is having a workspace for data ingest. Let's say you have a Kafka stream coming in. So you'd have a workspace that's specifically for that use case where data is only getting pushed to, and then maybe another workspace where you're actually running your analytical queries that are powering your dashboard. So those two workloads won't compete for the underlying resources. So just another high level, single store delivers real-time ingest, super fast analytics, as well as HTAP, as we discussed, hybrid transaction analytical processing. We are fully MySQL Wire Protocol compatible, support ANSI SQL. Just because we're MySQL Wire Protocol compatible doesn't mean we are built on top of MySQL. We are architected from the ground up to be the most performant hybrid transactional analytical database on the market. This visual here kind of tells the whole story. Single store gives you the ability to combine both transactions and analytics into the same database engine, supporting many different data types, and we can deploy anywhere. We have a cloud managed service that you can deploy in the hyperscaler of your choice. We can also deploy to bare metal, virtual machines, as well as in containerized environments. So for this next section, AWS and single store, my colleague Sarab will be coming up and discussing how we partner together and where we integrate. Thanks, Sarab.
Thanks, Gabe. Hello, everyone. So, as single store has been working really great with AWS, they have their SaaS solution deployed on AWS. At the same time, we try to build new integrations so that customers who are using AWS can have the best experience. And when it comes to all this data which has to be brought into single store from various places, you can effectively do that. So let's look into how we are getting that challenge done. So you see here, the core of the architecture here is single store. So the capability to bring data from various sources is what we offer right here. So there's native capability in single store, which you see single store pipelines, which is called out in the deck, where you can get data from file stores, let's say on-prem or on even your instances. Amazon S3, where you can bring that file formats and various storage formats which you can store on Amazon S3 can be brought into single store. And these native single store capability is where you ingest at a very effectively fast pace. The number of nodes which a single store cluster has works in parallel to ingest this. So you're getting that effective speed when you use single store pipelines. At the same time, you have streaming services, Amazon managed Kafka, or even other streaming services. You can use these pipelines to get effectively the data into your cluster. But at here, we are going to also look into AWS Glue, which can be used to capture data from various data sources and brought into single store using the single store connector. So we use the parallel capabilities here as well, because you use the Spark connector from single store effectively behind the lines, and which can then be used and deployed in Glue to capture data from various sources. And you're using that parallel capability of the Spark connector to connect to your cluster and do a very fast ingest even when you're using AWS Glue. Apart from that, you have various capabilities and point on bottomless storage, which can leverage S3 in the backend and store their data there. You can integrate single store with services like QuickSight for BI capabilities. At the same time, you can effectively use SageMaker capabilities and build your own machine learning. We are going to do a subset of that in our workshop today, but you can build a lot of machine learning capabilities and also look into AI services. There are a lot of AI services which we have built where you don't have to train your own models. There are models effectively already present, which you can use with single store and get that capability. On your application side, you can use different containers or Lambda services to effectively create microservices architecture, work with single store. There's a HTTP API which gives you that capability to use serverless kind of architecture. You also have private link capability so that all your applications can talk very securely with single store. At the same time, we would not effectively losing out on traditional applications. You can still use the JDBC connector out there to, so that you can bring in older applications and wire compatible applications and talk to a single store as well. So in today's lab and workshop, we are going to look into a simple use case. Is effectively not a very deep dive, but to look into what all capabilities are out there. So, and we expect you to explore more, think about more innovative ways you can use these services. This is just a getting started guide in a way to look into the analytical capabilities, as well as what are the different integration patterns which you can get started with. So we are using the IoT data from NYC taxi event stream. We will capture this by streaming Kafka service. Then we are going to do run analytics on it on single store database, and we're also going to capture a scoring mechanism which was developed which was developed in SageMaker. We are not going to do the SageMaker lab today, but we are using that score which was created in a SageMaker environment, and using that score to look into additional capabilities with Glue. Yeah. So this is the architecture of today's workshop, which I just said. We are bringing in Kafka events. So we will be looking into how fast and effectively using single store pipelines can easily get that data into single store. Then we are looking how we can use AWS Glue. Let's say if you have third-party sources or even AWS sources, which we don't have direct native capability in single store, we can still bring that data and even enrich single store data with third-party data. So that's the main use case here. And we will see how we can use Amazon QuickSight as a BI tool to, once we have all this analytics running, how we can display that in a dashboard. So we'll look into all those features. I will call on Gabe to help the participants get started with the guide. Yeah, thanks Gabe.
Thanks, Rob.
All right, so we are breaking the workshop here up into two sections with a little break in the middle. Section A is going to be all prep. You are going to get an AWS account provisioned. You're going to get a single store account set up and a cluster provisioned, a workspace provisioned. And then we're going to take a short break and then come back for part two, which will actually be creating databases, loading data, connecting to Kafka, to S3, and to Glue, and QuickSight, and that'll be our workshop for today. So let's get started with section A here. These are basically the steps that we're going to go through for section A. So if you have not downloaded the student guide yet, please do. That will be your instructions for the workshop today, both for section A and for section B. There's also a GitHub repo, which the link was posted in the chat here. So just have that for reference. So we'll make sure to do that. So I'm going to exit presenter view now, and this will be a little bit more interactive. I'll be jumping back and forth between a few different tabs for the rest of the presentation. Hope that's all right with everybody. All right, so we have the link here for the GitHub. I already have it up. There's this folder that was shared in the chat that has both the student guide and the presentation deck. More importantly, for workshop completion would definitely be the student guide, and then the presentation deck is just something that you can go through to see the slides that we have up here. We will go through the process to get AWS accounts provisioned for students. So download the presentation deck and student guide. This is the this is the folder where you can do that, and then decide which AWS account you want to use for the workshop. So you can bring your own AWS account with these 4 services accessible, but we have an alternative option where you can come into the student guide and leverage Event Engine, which AWS was nice enough to let us leverage for the purposes of our lab today. So if you come into the Event Engine link that's listed here and then paste in this hash code, I believe next will be prompted for your email address, and you'll put that in. And then when this all gets configured for you, you will end up at a dashboard that looks something like this. So once you get to this dashboard here, you can just click on AWS Console and then Open Console. And now I'm in an AWS environment, no need for complex configurations with IAM or your credit card or anything of that nature. Just a couple of clicks and you have this environment provisioned here. So big thank you to AWS for and to Saurabh for getting those configured for us. All right, so that is that on Event Engine. So the next step is going to be launching the single store DB cloud environment, as well as launching the AWS Cloud Shell services. So I have there's a bunch of screenshots in here, but I think it would be more productive to go through the student guide for this. So navigate to the student guide if you have not yet done so. And then we have a link here, singlestore.com/cloud trial. So if you navigate here, you can either sign in with your favorite SSO provider or just with a name and an email address. But anybody who creates an account on SingleStore will get $500 worth of free usage on our platform. And on our smallest environment size, that's about 1 month worth of use. So I already have an account here, but if you do not have an account, please navigate to this site and either create one via email address or via your favorite SSO provider. I'll close out of that. So once the ball gets rolling with account creation, you will end up landing on a page that looks similar to this. So I've already created a workspace group called AWS Dev Day, and I have one workspace within that workspace group. But when you create an account, you will be a net new user, and there will be no workspace group and no workspaces. So let's just go through the flow of what creating a workspace group on SingleStore DB Cloud would look like. And then from there, we can create a workspace and then get rolling with the rest of our workshop setup. All right, so AWS SingleStore Workshop is going to be the name of this workspace. We're deploying to US East 1 in this case, so that's fine. We can just leave it as the default. Given that these are sandbox environments, we are going to allow access from anywhere on the firewall configuration rather than configuring some fine-grained firewall rules. We recommend that all the students allow access from anywhere because if you don't, you'll have to go in and change the firewall settings to configure the pipelines. So the easiest method of going about completing this workshop today is just to allow access from anywhere for this workshop. The next step is to set a password. So passwords are at the workspace group level, as we can see here. So I just plopped in a password there. We're going to use the production release, that's fine. And then we have a auto terminate setting. That's optional. You may or may not see this in your portal. I'll just leave it as the default as 4 hours. So that was the workspace group configuration. So now we have the highest level object within single store DB Cloud created. So within a workspace group lives workspaces, which are our buckets of compute in single store DB Cloud. So the next thing we'll configure here is our workspace, which lives within that workspace group we had just created. This is a workspace. I don't know if we can have spaces actually, but now we won't be confused about what this is. This is clearly a workspace. It's labeled that way. Nobody get confused on that. Here are all the different sizes that you can configure with workspaces in single store DB Cloud. So we can see the default that it's going to populate is an S00, which is our smallest environment size in single store DB Cloud. That is 2 virtual cores and 16 gigs of RAM. And we can see that burns 1/4 of a credit per hour. If we click edit, we come and we get a list of all of the different sizes available within single store DB Cloud. And we define our sizes by number of virtual cores and amount of RAM. And you also get the associated credits that size will burn per hour, and then extrapolated out how much will that environment burn per month. You can see by default, because this is a trial account, the largest environment we can provision is an S16, but that is just a soft limit that's imposed here. That is by no means a hard limit in the system. We can configure environments all the way up to 3,000 plus cores, 24 terabytes of RAM within a single workspace. And if you have the money to pay for it, we could go even larger than that, but that is a very expensive compute environment. So for the sake of this exercise, we'll go with an S1. That is a happy medium environment size for a workshop like this, and that contains 8 virtual cores and 64 gigs of RAM. So that's plenty of processing power to crunch the data that we're going to go through here. The next step, you have this option to attach a MarTech database to, this is basically just a sample data set. I'm not going to include it because we're going to populate our own data in here. So there's really no need to populate that MarTech database. And now you would just click create workspace. And the workspace group as well as the workspace would get provisioned. I have already gone through that process, and I have a workspace here called Workshop Workspace in my workspace group, AWS Dev Day. So make sure you all go through that process to get both your workspace and your workspace group provisioned. If you're at this point, give yourself a pat on the back. Well done. And we're going to keep the ball rolling here. If you have any questions, either virtually or in person, just drop them in the chat or put your hand up, and we have resources who can come and assist you with that. So this is all the same configuration we were just going through. And the next thing is going to be to launch the Cloud Shell service. So before we launch Cloud Shell, I'm just going to do a quick, very brief overview of what we have going on here in the single store DB Cloud portal. So you can see that we're within our workspace group AWS Dev Day, and we have different tabs that you can view, like the number of workspaces in here, the databases, access, like your username and password, your firewall. As we said, we're keeping it open to everything just because this is a sandbox environment. As well as some monitoring and updating solutions. Within the portal here, we do have a native SQL editor, so you can just come in here and execute SQL statements against the workspace and the database of your choice. So that's a pretty cool tool. We also have some additional tools here, such as the ability to visualize query execution plans and every single step our optimizer is taking, and that really helps our customers optimize and troubleshoot particular queries. We can monitor things like workloads, active queries, pipelines, and then obviously we have a bunch of settings and user configurability within our portal as well. So that's a high-level overview of the console. Now we'll come back to the student guide. So the next step is going to be to launch our AWS Cloud Shell service and clone our GitHub repo. That's all we really need to do on this step 4 of our prep. So if we come into the AWS management console here that we were able to generate with Event Engine thanks to AWS, we can click right on the Cloud Shell up here in the top ribbon. And it'll just take a minute here for Cloud Shell to come up, and then we can get configured. Really nice things about Cloud Shell for today's workshop. This is like your Linux interface for your AWS environment, which already has Git installed as well as MySQL connectivity. And we talked about how Single Store is completely MySQL wire protocol compatible. So we will definitely leverage that MySQL connectivity later here in our workshop. So as we can see here, there's nothing currently in the directory that we're in. So our next step is going to be to clone our GitHub repo. So if we just come over to our student guide, we can copy that command and then come back to Cloud Shell, paste it in, and we can see that ran pretty quickly. And if we ls, we can now see that we have cloned that repo. So all good on that part. Super easy step 4 of the workshop prep. And we're going to do a lot more with Cloud Shell in part B. All of our data connectivity will happen in Cloud Shell, but we'll get to that in due time. And the final step is going to be leveraging a predefined CloudFormation template to create a stack, which is basically setting the groundwork for the glue ETL portion of the workshop that Saurabh is going to walk us through later. And he generously configured this for us already. So you can just click on this link right here. Make sure that you're logged into your AWS account before you do this. You click here, and he has an S3 bucket somewhere that just is going to populate this data for us. It has the YAML file, so we're going to be all good to go here. Accept the defaults template is ready. Accept default S3 URL, and the S3 URL will auto-populate here. So we'll click next. It's going to automatically name itself Single Store Dev Day. And this is the one piece that does not auto-populate with that CloudFormation template because it's unique for every student. And that is going to be your cluster endpoint right here. So I will show you how to find your cluster endpoint right now, and we will plop it in there. So Single Store has a lot of different connectivity options. Being MySQL wire protocol compatible, you can pretty much pick up the majority of MySQL drivers and connectors off the shelf, and they will work just fine with Single Store. And we're going to leverage some of that functionality right here. So we're going to connect directly into this workspace, and let's just go through some of the different connectivity options here. So you can do a CLI client connectivity option with either a MySQL connectivity string, which we'll leverage later in Cloud Shell, or you can just get the raw endpoint if you prefer. You can configure with SQL IDEs, SQL Pro, MySQL Workbench, whatever it may be. I personally like dbeaver, so I connect into my, yeah, there we go. We got some dbeaver fans out there. You can plug right into whatever your application language is. So we have some pre-populated code for some leading application programming languages out there, as well as BI tools. So we have pretty robust BI tool connectivity. Most of the leading industry visualization tools, and later we're going to show some more functionality in the BI space when we connect to QuickSight. So that was just a quick little overview. Back to the actual content of the workshop. We're going to connect to the workspace. So for the CloudFormation stack, we needed the URL. So if we come to single store endpoints, we can just copy this URL here, but notice how we have a :3306 at the end. So that is defining the port number. So what we're going to do is make sure that we have that copied to our clipboard, this endpoint, and we'll come back over to our CloudFormation stack and paste that in, and then make sure to backspace out that port number as well as the colon, because that's going to throw some errors if you don't. You don't need to define the port number here. All we need is the vanilla endpoint, and that will be sufficient for the workshop. The database is automatically going to configure to New York City Taxi. That database does not exist yet, but it will by the time we leverage this CloudFormation stack. The username by default in single store DB Cloud is admin, so that's standard for everyone. And then we'll plop in the password that we set when we created our workspace groups earlier. We'll click next. And at this point, accept defaults for everything, and you can just click your way through. Acknowledge that you're doing a thing, that you are creating a AWS CloudFormation stack, and it might create IAM resources. In our case, I do not believe it is. All right, so kick that off. The CloudFormation stack creation usually just takes a handful of minutes. So while that is running, we will navigate back to the student guide here and see that that was the last step of section A. So we're going to pause for a quick break here. Now that we have our AWS account provisioned, we have our single store account provisioned, we have a workspace group and a workspace provisioned. This is a natural breaking point. So I will pass to Matt, who will be running through some questions here.
Yes, let me turn on my camera here. I think that's working. All right. We have developed a quick audience poll and quiz for everyone. If you want to check your GoToWebinar screens right now, I'm going to see if I can figure out how to activate this. And launch. Great. So the plan here is feel free to answer this poll if you are online and awake. The question here is, how many tiers does single store universal storage have? So please select one of the following: 1, 2, 3, 4. Anyone who answers this correctly will get free single store swag delivered to your address. Rest assured, virtual or on site, we can get this to you. I'll track you down and follow up with you if you are one of our virtual attendees. It's like I'm getting quite a few polls in here. I'll let that run for maybe 30 more seconds before I shut this down. And then Gabe, maybe I can, once I shut this down, I can turn it back to you to kind of explain the correct answer. Is that how you want to handle this?
Sure.
Okay. Great. Thanks. All right, I think we've got, I'm seeing 100% or 91% voting. I'm going to go ahead and shut it down now. It looks like 90% say answer number 3, 10% say 4. I'll let you take it, Gabe.
All right. Thank you for that, Matt. Fun little questionnaire there. So we did discuss single store's universal storage architecture which spans 3 storage medias: memory, SSD, and object storage. The correct answer is 3. So if you answered 3 in our GoToWebinar, Matt is taking note of who you are, and he will be sure to get you some swag, whether you are here in person or whether you're virtual. We'll be sure you'll get something cool here.
Good stuff.
Good stuff. All right, so yeah, I guess we'll get right back into it here. Section B is going to be where we're actually doing.
Okay, quick question, if I can jump in here.
Yeah.
See, we've got a couple that are coming in. Give me a second. Okay, so the first one here is, can a workspace include both AWS/Cloud DBs and on-premise?
So that is a good question. Workspace groups and workspaces are solely single store DB cloud managed service offerings. We do have a self-managed offering where customers can take our licensed units and deploy on their own infrastructure, as we discussed, bare metal VMs or containers, but those are not part of the workspace group paradigms. Those would just be machines clustered together into a database cluster for the on-prem scenario.
Good stuff. And the second question is just about the student guide and GitHub. I have posted links to that for any late arrivals in the chat. I'll post it one more time. But yes, you should have what you need from those download links. Take it away, Gabe.
Awesome. Thank you, Matt. All right, so we're gonna kick off section B here, where we're actually going to do cool things with data, which is why we're all here. So breaking down section B into a few different steps, we're gonna set up our database, create our tables, and we're gonna load some data. To load our data in, we're gonna leverage our pipelines that we discussed earlier, both with S3 as well as Kafka as sources. We'll then deploy a real-time stored procedure just to show some additional functionality of the database engine. And then we're going to pass to Saurabh so he can show us how nicely single store integrates with both AWS Glue as well as Amazon QuickSight for ETL functionality and for visualization respectively. All right, so step 1 of section B is to set up and load our data. So I'm going to jump back to the student guide here in a minute, but just a few tidbits to review first. We are going to be leveraging a very popular open source data set, New York City taxi and limousine data, and we're going to create 3 data sources and populate these into 3 different tables. We're going to have a trips table, a drivers table, and a neighborhoods table. And just here, I can make this a little bit bigger so we can see a little better. These are sample records for each of those associated tables. So we can get a better look at this once we load data into the database. But basically, trips and drivers is pretty standard, like when it was requested, where it happened, price, all that kind of stuff. And neighborhoods are actually a geographic outline of the coordinates, as well as the neighborhood and the borough, and some other uniquely identifying information about that particular neighborhood. So we have these 3 pipelines that we are going to configure, 3 different data sources. 2 of them we're going to be streaming in, and 1 of them is going to be more of a bulk ingest. So we'll be streaming in the drivers and the trips data via Kafka pipelines into, via Kafka in our pipelines integration. And for our neighborhood data, we'll also be leveraging our pipelines functionality, but rather than Kafka as the data source, we'll be using S3 as the data source. So we're choosing a few different data sources here to demonstrate the ability to handle both streaming and batch ingestion into our database. So we'll jump back to the student guide here. So we have some pretty URLs for the Kafka streams, but we actually are going to end up using these ones because these are the beefier machines. Don't worry about copying and pasting any of the specific IP addresses of the machines or any of the metadata around that specific topic. It's all scripted out for us in the GitHub, so you're just going to reference particular SQL scripts, and those SQL scripts will execute everything you need here. All right, so step one is going to be to create and load data into the database. So first and foremost, we already did the git clone of the AWS Dev Day directory, and now we are going to navigate into that directory into section B. So if we come back over to Cloud Shell, we just saw this ls, we have AWS Dev Day. So if we change directory into AWS, and we don't have to type the whole thing out, we can just put a little asterisk. Same thing into section B. Here's where we need to be, and we can ls and we can see all of the different files that were part of this git clone. And similarly, if we come over to the GitHub profile and pop into section B, into the GitHub repo here, we can see all of the different SQL scripts that go into this workshop. All right, so now we are in the right directory. From inside of that directory in section B, we are going to initiate the connection to the single store database via Cloud Shell using MySQL Wire protocol connectivity. I know that's a mouthful, but it's super simple. It is pretty much a copy and paste command. So we're going to navigate back to our single store DB Cloud portal. Hopefully by this point, everyone has a provisioned workspace, and we're going to use this connect button again here. So we're going to connect directly, and it's this first page right here, MySQL client, the MySQL connection command. So we're going to copy this, come back over to our Cloud Shell, paste it in, and now the only thing that you need to change about this connection string is without any spaces, type in your password. So this is going to show as plain text, which is fine. There's no sensitive data in here. This is a sandbox environment for me, so it's no big deal. So I'll type in my password, and we're going to initiate that connection. So we can see that we have the MySQL cursor here, and this is indicative of us being in the database. So let's see what databases are here right now. If I can type, I can't type. Show databases, yeah, duh. Okay, so right now we currently have 3 databases within our environment. The main one of note here is information schema, which collects and stores a bunch of metadata from our environment. So things like, cache information, pipeline information, a bunch of metadata around the workload, all is going to get persisted in an information schema. So we're going to pop back to our student guide here. And the next step is going to be creating our table schema. So we can copy this command right here. So source is going to reference files in that directory that we initiated our connection from, and then create NYC tables DDL is that SQL script that is going to create all of the tables for this workshop. So we're going to run that here. So this is doing a few things. This is creating our NYC taxi database. This is then indicating that we want to use our NYC taxi database, and it is creating, I believe, a dozen tables. So now we can see that we have successfully executed the command and we are inside the NYC taxi database. So now if we do show tables, I believe there's a dozen different tables that got created with that statement. So now we have our workspace that we successfully connected to. We created a database and a bunch of tables within that workspace. Awesome. Let's pop back to the student guide and see what's next here. Basically, we already went through this a few minutes ago. These are just sample records of each of the different data sources that are going to come in to the database. So our next script that we're going to run is going to be create NYC taxi pipeline. So you can just copy that. I'm going to actually pull it up in the GitHub here, just so we can take a look at, here I can zoom in a little bit, just so we can take a look at what a create pipeline statement in single store looks like and how easy it is to configure. So it really only is a few lines of SQL code to establish these connections. So for example, we're creating the driver's pipeline first. We're loading data from Kafka. We're inputting the endpoint of our Kafka topic. And then we have some, a batch interval. We say the fields are terminated by commas and so on and so forth. Very similar for the trips table. What's for the trips pipeline into the trips table. And what's different about the neighborhoods pipeline into the neighborhoods table is we're loading data from S3 rather than from Kafka. And similarly, we have the folder directory structure to this S3 bucket. Yeah, so that's pretty much how easy it is to configure to create a create pipeline statement into single store DB Cloud. So now that we saw what a create pipeline looks like, we can actually execute that create pipeline we just looked at, which is going to kick off our 3 pipelines. So if we run show pipelines, we see that we have these 3 pipelines that just got kicked off, but they're all in a stopped state. So now these pipeline entities exist in the database, and now the next step is to kick off the data to actually start populating here. So we have another script to do that, which is our start NYC taxi pipelines script. So if we source that script, we can see that it executed, and now if we run the show pipelines again, we can see that all of these are in a running state. So to verify this, we can come back over to our single store DB Cloud portal. We can come into databases. We can see that we have 3 tables that have data populated, and all of the data is successfully getting streamed in to those 3 tables. We can see the database has been created and it has a read-write relationship with our workspace. We talked very briefly about the information schema database earlier. So basically, the information schema database contains a lot of metadata about everything in the cluster, pipelines being a subset of that. So here are just some different tables within our information schema database that you can query to get some really good metadata around pipelines, batch times, how many things failed, errors, all that good kind of stuff. All right, so let's pop back over to Cloud Shell and just take a look at the data in here. So if we, you know, here, if we do select all from drivers and we limit it to 5, we can see that every driver that's coming into the system has a unique ID, obviously a name, the location that that driver is currently in, where that driver is heading, the status of that driver, as well as the trip ID. And if we run a similar command for our trips table, we have the trip ID, what the status of it is, where did it start and stop, and a bunch of other metadata. When was it requested, accepted, picked up, dropped off, how many riders, how much it cost, etc. And finally, this one is going to be pretty ugly, but we can also select from the neighborhoods table and get some large polygons back, which don't really look nice, but the data's there. That's what matters. All right, so now we have created these streams that are populating our single store DB Cloud database. So now that we have some data, let's run some queries against it and see some of the analytical capabilities of single store DB Cloud. So I believe we have 7 or 8 different analytical queries here. Total numbers of trips per neighborhood, average wait time, average distance, and so on and so forth. We, in the next step, will be deploying a stored procedure that iterates through every single one of these analytical queries. So I'm not going to manually go through and run all of them right now. I'll just run the first one so we can take a look at just one of them. So the first analytical query is the total number of trips in each neighborhood. So that's a pretty useful piece of information. If we plop that in here, we can see it ran in about half a second. And then we have a ranked list of how many trips are occurring in each one of these New York City neighborhoods in real time. So no surprise, leading the way is Midtown, Upper East Side, Chelsea, so on and so forth, with thousands of rides requested, and we get all the way down to some of the less popular neighborhoods that have only a single ride. All right, so the next step is going to be to deploy a stored procedure which iterates through a bunch of these analytical queries in a loop. So the purpose of this is to demonstrate the ability to process data that is in the database already and then persist those results back into the database. So imagine you have some data coming in, you need to do some calculations on the data once it hits the database and you want to persist those results. That's exactly what this is going to demonstrate here. So these are all the different analytical queries, and we're just going to jump up to step 2 because our analytics stored procedure is going to run all those queries again anyway. So what we're going to do, once we create this stored procedure, it is going to loop and it's not going to end until we Control-C out of it. So instead of saturating this Cloud Shell session, I'm going to duplicate this tab and start an additional Cloud Shell session so we can saturate this one. So I'm going to CD back into that section B directory. And then we are going to, oh, can I just do this? No, it doesn't like that. We're going to reconnect to our MySQL endpoint. We'll plop that over. And now we are in. Okay, so we want to use NYC taxi. All right, so now if we navigate back to the student guide, our next script that we want to call is create derived stats. And create derived stats is just a script that loops through these 8 different analytical queries continuously until we manually break it, and it's persisting the results of those analytical queries back into database tables within the same database. All right, and it has been created, and now we are going to kick it off with this script right here. So we can see there's one iteration. So that one iteration was a successful run of all 8 analytical queries. There's another 8 more analytical queries. And this is just going to continue to loop and loop until we manually kill it. So in real time, as data is getting streamed into the database engine, we can continually run this stored procedure, run all of these analytical queries, so that all of the fresh data is successfully being analyzed in real time as it's coming into the system. And then we're persisting all of those results back to the same database here. Yeah, and the next step is going to be configuration with Glue and with QuickSight, which my esteemed colleague Saurabh is going to lead. So I will hand over the floor after I stop sharing my screen. I'll turn my mic off.
No, am I sharing my screen?
Yeah.
No, right.
Make you presenter in case that helps.
Yeah. Yes.
Here you go.
Yes. Yeah.
We can see if we go to webinar.
Not yet. Okay. So what I'll go through here is we are going to showcase the fast ETL capability between a single store DB using AWS Glue. So before we connect, I'll just go over what's the main premise. We did create the CloudFormation script. What happened was it created the IAM role, which we need for setting up this, as well as AWS secret, so which we'll be using for connecting to the environment. So that's already configured. We will be creating a Glue connector and a Glue job. So it will leverage Spark capability and the Spark connector to get the configuration going and getting some data. So here what we have is we have pre-trained data, which is already trained using SageMaker Glue in a S3 bucket. And we're going to just load that in the environment. We're going to change and apply some tagging so that change the mappings for the data and load it into single store. And once we have loaded it, we will then move on to doing connectivity with QuickSight. So here we have a marketplace connector which is already there for single store. Today's environment, we have used Event Engine AWS accounts, so you don't have this capability to subscribe to this connector through that provisioned account. But what we will go into is steps so that you can use a custom connector capability. So let me go into that detail. So once you go and this is the AWS Glue Studio. So if you type in AWS Glue here, you should be able to go into the AWS service in for your account. Then you can go to connections, and in these connectors, go to the create custom connector. So as a part of this, I have added the Spark jar to a public S3 bucket, which you can leverage from the student guide. So in the student guide, we have instructions for the S3 URL. I'll copy those over. We will select the connector type as Spark and com.singlestore.spark is the class name. We can add single store custom as the connector name. You can also add a description or version numbers if you want to support different versions of the connector. So once you create hit the create connector, I wouldn't do that because I have already connected in place, but once you hit the create connector, you will have a connector in play here. And once you have a connector in play, this is just a default connector. It doesn't have any configuration details to connect to the specific workspace which we have. So we will create a connection. This will be specifically used to connect to the specific environment. So you can use the same jar file but connect to different environments. In here you would see there is uh, you know you would see a specific secret which is already created for you. So you would be able to select that and name your connector as single store custom connection. Right? So you would be able to name specifically your connector, and once this is you do a create connection, a new connection will be created for you, which will look something like this. It will showcase the connector URL details. It will showcase the class name. Once you have the custom connector created, you can click on the create job here, or you can go onto the jobs section in the navigation panel on the right. And if you see here, the various sources, right? As I was talking, what Glue provides is a capability to bring in data from multiple sources onto any other target. Here on the target side, I can specifically select a the connector which you have created. So I'm selecting single store custom which I have created here. And on the source side, I will just select Amazon S3 as the connection. And we will keep the visual source target. So here, by doing a visual editor, we are able to use the Glue Studio to actually do a UI representation of all the Spark transformations which we'll be doing. Once I do a create here, it creates a new job for me to edit. I have the main source and the target as well as apply mapping. So we'll be doing a simple transformation here, which will just apply mappings. But you can add your own script as well as add additional transformations here and add multiple sources. So it doesn't have to just be one data source. It can be multiple data sources as well. So I'll be naming the job. So I'm naming it as single store job 1, and before I run the job, I want to change the job details as well. So I have to give it adequate permission so that it can read from S3. There are cases where you are using different sources. You might need to have adequate permissions there. Here we have created a role which has adequate permissions to read from S3, as well as permissions for the secrets manager. So we are like tightly controlling this. Security is considered as job zero at Amazon, and so we have ways in which we can control the amount of permissions. So your specific jobs only have access permissions to do specific activity. Once you select the IAM role, and in here for this job, it's a very not a very job which will scale a lot of data. So I'm going to keep the number of workers as 3, and I'm also going to disable the bookmarking. Bookmarking is basically, let's say, if you're constantly update data which is getting updated, or you want to break in between and continue afterwards, that's where bookmarking comes into play. So I can just disable the bookmarking, and I can keep the for when you're testing things out, I would say you can keep the number of retries to 0. In production, of course, you want retries if something fails, but when you're testing things out, you can keep the retries to 0. So once I've set this up, I'll do a save for the job details. I still have to add inputs here for my data source and target. So on this source bucket, I will get that information right from the student guide. So yeah, we do have instructions where we use the marketplace connector as well in the student guide. We did use the custom connector, but in case you want to do this on your own AWS account, you can look into the student guide and work with the marketplace connector as well. We have a public bucket here on the as a source, so you can use the S3 single store dev files as the source bucket. So I'll be selecting S3 location here and adding that file. I can do a infer schema. I believe it's something to do with the the text here. If I retype it, it works. And I believe it's something to do with the characters which were there in the file. So if you do the single store dev files, it should work. So this does have an autosave on it. In case if things don't get saved, do remember to save your job details. There is a additional activity you have to do. The presently on to work with the data preview feature and do mappings. There's a specific requirement that I have to set these to strings. This is not a requirement if you're working with glue catalog. So if you process the data with glue catalog, this is not the specific requirement, but in here we are directly reading it from S3. So I have to just map these as string so that I can do transformations on it. In these transformations, we are getting anomaly data, and we are having a score associated with it. Presently, my plan is to not decide the anomaly based on what is coming in the SageMaker, and probably use a standard deviation for anomaly later on. So I'll ignore and drop the Boolean data here. I can rename the target key values. So I'm just renaming the score, and I believe we are doing them to be number of riders and time ID. So yes, I'll do that. So we change the target key values. You can of course do more transformations. I'm just limiting this to showcase the specific use case here. And in the final case here, I select the connection details and I select the option. Here we have a table which we can connect to. So we are going to name this table as NAB NYC taxi scored. So let me do that. So once I have added this information in here and I save this data, I can yeah, once this data is saved, I can run this job, and so this data can be will basically create a new table in the database on the single store side. We can also do a preview on Glue to actually look into what data is being pushed onto single store. So yeah, so this takes a while to run into what you can preview the data before you run the job, as well as once your job runs, you can look into the details on either your job details and stuff right in this tab. So there are these different tabs which gives you control over your Glue jobs. So as this job is running, we can look into the specific table on the single store side as well. So let's do that. Yeah, so we see that the table is created. And we are still waiting on the data to be populated here. Yeah. Okay, so on my side, I probably used the wrong secret. Yeah, so I have multiple IAM roles, so I used a different one. So let me change that. Or even change the permission. Yeah, so here, let me edit this to a little more expansive. So I'll make it more generalized. So, but as you see, you can have prefixes in the secret as well and limit them to specific secrets. have the job here. I will run it again. As our job is running, I also want to showcase the next steps around quick site integration. So as a part of this, on the quick site side, we the main idea behind it is single store is MySQL wire compatible. On the quick site side, we have capability to bring in different data sets. So we can bring in MySQL as you're going to choose the MySQL as a data set, but actually underlying use the wire compatible single store capability to bring in that data set. So here we will be doing that to effectively bring in all the single store data and create a simple dashboard, showcase how easy it is to bring in data and create a dashboard on QuickSight. So in the student guide, if you move on to, you see there is a new data set option where you can bring, and we are going to bring in trips and neighborhood data in the data set. So here for this, you will need the need your connection details from your single store connection. So let's bring that. We can add a new data set here. Select MySQL, bring in your details like trips. On the database connection which you have, you can of course, let me go here. Yeah, so let me bring the details here itself. I'll bring in QuickSight. I'll go over the workspace, copy the connection, go on to the data set, new data set, and I'll select MySQL, add the database server name, port is 3306, database will be NYC taxi, username is admin, you can put in your password. I don't enable the SSL here because it's a test configuration. So, and once you have added your password, you can validate your connection. So to check if everything is working fine. Yeah, so once you have the connection validated, you can create your data source. I have trips data source already, so I'll create it at trips one. And here you have to select which so which table you want to bring in. So you can select trips table. You can do the similar, and here you have different options. So we are going to import this data into Spice. Spice is like a caching engine where you cache the data. So let's say if you have a lot of data on your single store side and you want to bring in subset of the data onto QuickSight for faster loading, you can do that. But let's say there are certain analytical queries, for example, KPI metrics like top average ride metric or certain things where you want to directly query single store, use the appropriate mechanism. Like based on the BI tool, you might have to select some queries which you do to do the KPI metric, select the direct query to your data in that case. And for some metrics where you want to bring in all the data and show it in a chart in a chart manner, select the import to Spice. So here I'm just using import to spice, but depending on your KPI metrics like average riding, average ride times, or ride cancellations, you can create a KPI metric and do a direct query on it. So once you have this data on the trips, I will also bring in data for the neighborhood similarly. So on the data set, I will also create another one, which I've done here, one for the neighborhoods. So once you have created the two data set, trips and neighborhood, you can actually go ahead and join different data sets as well. So here I'm going to do a join between the data set. I have the trips data set here. I can add additional data here, select a data set, neighborhoods. And once I select this, I can do different type of joins like inner, left, right. I'm doing a right join here, and you can join on different IDs or tags. So I'm selecting the ID for the trips and the neighborhoods and matching those. So once I have matched those, I'll apply. So now we can actually relate that data and create a chart which makes more sense. So now we have this. Let's go ahead and see how we can analyze this and showcase this in a graphical chart. So I can go here back again. Once we have this trip analysis, in this we have the data for both the neighborhood and the trip. I'm going to just select which main table like columns I want to create the data set. Right? Let's say boroughs. I want to select like the boroughs and names of the places, and let's say price. So QuickSight is intelligent enough to understand that what kind of charts you might want with these columns. So it did aggregation for the price. So you see, did a sum of the price, and it's giving me the top 50 names and in top 6 boroughs. So it's giving me which are the topmost like price based on the taxi fare pricing. It's accumulating that and giving me what are the top names in different boroughs. Apart from this, you can just select other set of let's say I want to see which like what are the right prices aggregated in a separate borough. I can just select boroughs and prices, and it's giving me in this format, but I want to show in a different format. I can just select a pie chart here, and it will just convert that into a pie chart. It'll show that Manhattan is 13% of the pricing, total price, and Brooklyn is 24%. So it's showing that charts can be made in a very simple way. You can just select the columns, but again, you have control that you can edit these and go in a specific way in which, let's say you don't want a sum, but you want to have it in a different format. You have the capability to edit those and create a new chart. Once you are done with the creating these charts, you have capability to uh, save these and then even publish them or print them or publish them, so that these can be embedded and shared across the board. So let's say you want to share this as a report. You have capabilities to do that and even share this as an embedded report. As I said, like a lot of times with single store with the real-time capability, you can have your KPI metrics. We did some queries to actually get some metrics for the data. You can bring in those special queries as well. So let's say I can add. Let me go back to the data set. A new data set. Again, I would specifically add this as a query. I believe I will have to capture the server port name again. And if you see here, custom SQL, so here you can actually write your own analytical query so that that query runs against the server. So that way you can bring in any KPI metrics and publish it on QuickSight. Let's go back and check on the Glue Studio here. So yeah, I have single store secret, and that's why it's not running. Let me go again here. Edit this. Yeah. So that I have that specific secret here. I think I missed to save this part. Is it? Okay, it's showing the reflect. Yeah, yeah, I missed saving this part first. So yeah, it's still not running. All right. And let me also bring in a query here from the student guide. So so let's say I want to have the average wait time, right? So this query to be reflected. So you can bring in something like average wait time as a metric and showcase in QuickSight. So that way you would be able to get that as a KPI, and you are basically following that the wait time target should be lower. Yeah. Oh. On the blue side. Yes, it's successfully started the job. So we'll just wait to get this running. I believe it was just the permission issue with the IAM role. So that way, you have seen I have created the CloudFormation script for all of you guys. So with CloudFormation script, just having the environment in the proper way helps to get this kind of out of the way. So once you have your infrastructure as code, it helps you get things out of the way. Yeah. Yeah, so this is something I will have to look into. On the participant side, anybody has been able to run that glue job without any issues?
No, I have a question that's ongoing, which has the same issue.
Question from the chat. I don't know. It's says I'm missing permissions when I try to subscribe to the single store Glue connector. Some controls have been disabled, missing permissions. I'm using the event engine. Ran into the issue while trying to add the AWS Glue single store connection. In the student guide, section D, follow step 3A instead of 3B. Event engine does
not have the appropriate permissions to access subscriptions in AWS.
Yeah.
So we need to configure a custom subscription.
Yeah, we just need to create a custom connector here and not subscribe. So the subscription is something to take away if you're bringing in your own AWS account. Just due to legal implications, when we have these workshop accounts, we don't let them subscribe to AWS Marketplace objects. But yeah, so they can just use a custom connector for now, and there are instructions in section 3A, as Gabe said.
3A. Okay, got it.
Yeah, I believe you guys should be able to use the glue job and run it. I'm having issues on my side because I'm not using the provision account here on my side, but you guys should be able to run this without any issues. Yeah. I'd like to invite Gabe to as a to follow on the next action items on this. Let me change the presenter.
All right. Thank you, Sir Rob, for going through the glue and the QuickSight connectivity. That wraps up section B. So the hands-on piece of the workshop is all wrapped up here. So if we navigate to the student guide, I mean, you can run this script to stop your pipelines, but every event engine account is only going to be around for another 24 hours, and then it's automatically going to get blown away. So no need to be super uptight about deleting all those resources to mitigate, like the environment will get blown away in 24 hours. So if you want to go through and delete your CloudFormation stack and things of that nature, go for it. From the single store side, anyone who created an account today gets $500 worth of free credits. So the environment you created today started to consume those $500 worth of free credits. So you have a few options. You can come into the portal and terminate your workspace, obviously, and then it's gone for good. You can suspend your workspace, or you can keep it running and continue to play with it here. I'm going to choose to suspend my workspace. So you can go ahead and do that, suspend. So now the workspace is in the process of suspending. And a nice part about the 3-tier universal storage architecture is that even though we're spinning down all of the compute associated with our environment right now, our database is still around. It just lives in S3 for the time being. And when it comes time to leverage this database again, we can just spin up a new environment and rehydrate it. So that is about it. Just quick recap. AWS is a great partner for Single Store. We are very thankful for the relationship and look to continue to bring value to our customers together. Single Store is a real-time distributed database for all types of workloads, both transactional and analytical. Many different use cases, many different data types, all powered by our patented universal storage technology, which has that 3-tier architecture that we've discussed today. Next steps, I have a Calendly link here. If you want to get some time on my calendar to talk more about single store, talk about how we partner with AWS, talk about your favorite sporting teams, what you like to do on the weekends, you can do so here. And that is it. So big thanks to Saurabh for joining us from AWS and co-presenting today. Thank you for all of our attendees, both in person and virtually. And thank you for all of the supporting staff here as well from Single Store and from AWS. So I'll pass back to Matt here. Thank you.
Awesome. Thanks a lot, Gabe. And thank you, Saurabh. Thank you also to our audience. Everyone's going to automatically get a video recording of today's session. As Gabe mentioned, we would love to chat further with you. You can check out our training resources at training.singlestore.com, or you can book time directly on Gabe's calendar. As he mentioned, I'm going to put that Calendly link into the chat. If you have any questions for him, if you want to dive deeper, so check that link in the chat. And then thanks again to everyone for joining for the Seattle folks. Please feel free to join us for drinks. We're going to go to the Wakefield bar, which is a 6-minute walk from here. We can walk together if you like. We have a bar tab open, sponsored by courtesy of Single Store. So we would love to hang out for a bit if you would like some drinks. Thanks again to everyone. It was great having you today.